Good afternoon, ladies and gentlemen, and warm welcome to a webinar by EQ Magazine and powered by Sinning Electric on inverters, pricing, demand, supply, and technology roadmap, especially focusing on the utility scale inverters. I warmly welcome our distinguished panelists. First of all, our moderator, Mr. Blak Singh Ji, Senior Associate, National Solar Energy Federation of India. Our keynote speaker, Mr. Subir, Deputy General Manager, Engineering, NTPC. Mr. Sanjeev Jha, Head of Business and Operations from U Solar Clean Energy. Mr. Srinivas, Vice President, Group Quality, Greenco Energies. Mr. Ashutosh Singh, Head O&M, Acme. Mr. Arun Chaudhary, Head Sales India for Sinning Electric. Mr. Sarvesh Singh, Head SCM Azure Power. Mr. Chaudhary, CEO of AMP Energy. Mr. Sudhir Pathak, Head Central Design and Engineering plus QA from Hero Future Energies, and Mr. Sanjay Singh, Lead Design from BVG Clean Energy Limited. So, ladies and gentlemen, welcome all of you. A brief introduction about myself and EQ. So, we are a 13-year-old company. This is our 14th year in the solar sector. So, we have been publishing monthly magazines, daily newsletter. We have a daily updated news website. We do numerous kinds of events, conferences, webinars, product launches, buy-sell meets, trainings. We do publish research reports, research-based solar map of India. We do research-based awards. And we have a HRV, geographically spread across Southeast Asia, Central Asia, Middle East, and Africa, and covering solar, e-mobility, and hydrogen. And what recently we want to do is a few interesting things. One is we are doing a survey on best renewable energy companies to work for. And I hope you must have seen that survey form. So we request everyone to please fill the survey form. The last date is 31st of May. Secondly, our events are coming up, like we're doing an event in Pune, in Coimbatore, and then as a follow-up, we'll be doing events in more cities such as Bangalore, Hyderabad, Jaipur, North in Chandigarh, in UP. So more conferences, award shows, and mini exhibitions are planned. Then we're also bringing back the Inspire Series 2.0. I hope 2 years back, when the pandemic hit all of us, we did the Inspire Series Part 1, in which we interviewed all the top-notch renewable energy companies CEOs. And last year it was nothing new to catch up, but this year we have lots and lots of new things. So we are doing the Inspire 2.0, and we already have confirmation from AMP Energy and Hero Future Energies. So those two interviews are lined up for the next month, and we are hoping that other CEOs also would confirm shortly. So that is going to be also a regular exercise. So this is a brief about us. Before we go ahead, I have an interesting video for all of us to watch and enjoy. So. So thank you very much. Interestingly, the space of renewable energy has really transformed itself in the last couple of years. As we have seen the issue of coal, we've seen fuel prices rising, we've seen the issue of energy security, increasing trend towards decarbonization, increased demand of power, increased penetration of electric mobility, and international events. And recently, with advancements in carbon markets, the renewable energy companies have started to get the realization of the environmental attribute of putting these renewable energy power plants, which was totally missing since last many years. So the sector is progressing extremely well, and I think it is definitely, I think, a start of the new era altogether. So, without further ado, may I request Mr. Vilak Singh ji to please take the webinar proceedings ahead. And I request all speakers to please let's focus on this topic of inverters roadmap regarding technology, pricing, demand, and supply. I'm extremely excited that we have an expert level panel who is going to enlighten all of us. So I'm very thankful to all the panel members, and good response. I think right now 50 people are there, more than, as I can see on the back end, more than 125 people have registered. So we are expecting more people to join, and plus we have it as live stream. So nevertheless, Abhilak Singh ji, may I kindly request you to please take the webinar proceedings ahead. Thank you. So you are on mute, sir.
Okay. Yeah. Now it is okay.
Yes, sir. Fine.
Yeah. So thank you, Mr. Anand, and good evening to everyone. Mr. Anand, you have chosen a very nice actually topic, and I think in last 2 years, first time exclusively on inverter. This webinar maybe, but I would have not attended. But of course, many programs are also going on. So this webinar is on inverters, pricing, demand, supply, technology, roadmap, utility scale, solar, science, electric. So actually, this what I recall when I was in doing a graduation, my graduation project, and incidentally it was on inverter. And inverter, so of course not directly on inverter, but using the inverter, so some AC drive, etc. And so the main important part was, my project was to design this firing circuit, and then control, how to control the speed and all that. So at that time, actually, nearly 40 years back, I never imagined that today the inverter will become a street items. So like it become a, for last 20 years, street items for home inverters. And of course now this power plant, solar power plant, it is the main actually component of this entire solar power plant. And see now the innovations now, incidentally, when I joined the government of India, Ministry of Electronics and IT. So in the first month itself, we have received the inverter of 7.5 kilowatt from Apple Thane. And I was in charge for that till I was there in that laboratory for 8 years. And this this 7.5 kilowatt inverter was in this 10 by 10 room, and it was making a noise, and which was that noise actually disturbing 50-60 meter away where my entry gate was there. So then what I see today, the inverter actually sizing, the size has actually the size become so small, and in fact up to I think 50 kilowatt or something can be on ball mounted. that I saw, I think in Sarda University, this while in Ereda, um, uh, they have actually 100 kilowatt. We have sanctioned 1 megawatt, and they have put it on 11 roofs. So all inverters was on the wall. So with this little background, and see now, in last 25 years, incidentally, most of the time I was in handling the solar in Ereda. And in fact, initially I was in charge for manufacturing activities also. And for inverter also, we have sanctioned one project. And at that time, it was actually only up to 5 kilowatt, though that company has requested for 100 kilowatt. So then we put a condition that you first do it successfully 5 kilowatt. Thereafter, we will do this next stage. So that was there. And the pricing, see now in 94, 95, the price was too high. And in fact, at that time, the inverters was very small, and the solar plant itself, I think the first solar plant came up in Coimbatore wind, hybrid wind, that was 100 kilowatt, funded by the World Bank through Ereda. And thereafter, this 300 kilowatt biggest plant was Steel Tubes of India, Devas. And then I think the similar size was in Punjab, Khatkhat Kala village of Sayyid Bhagat Singh. And now what we see, 2010 onwards, the size of solar power plant becomes itself is very huge. And at that time, even first project we sanctioned at Reda, that was involving 1 megawatt and 2 megawatt. And whereas this NTPC Vidyut Vyapar Nigam Limited, they were given the 5 megawatt and 10 megawatt range. And now what we see today, the big solar parks, etc. With this little background, now I request Mr. Arun Chaudhary, Sales Head India, Signage Electric Company Limited. Please, Mr. Chaudhary.
Mr. Abhilak, you have rightly said the industry has gone so far from 1996 to 2022. I recall in 2010, the total installed capacity in the India was around 120 megawatt. Yeah. And that was a substantial capacity which India can be proud of on that time. But now, you see, now we are planning for, earlier we have planned for 100 gigawatt. Now we are planning for more than that. Total installed capacity in India is total, means the solar capacity which can be installed in India is around 950 or 970 gigawatt. Nowadays, we are seeing a lot of changes in the inverter technologies. Earlier, the inverter was so big, but now it has become so compact. Even sometimes we are suspicious whether they can sustain or cannot sustain. Like the earlier size of the 1 megawatt was quite big in size. But now even the 5 megawatt, the 3 megawatt inverters, they are very compact, and they are much refined design. Other than that, now we have a capacity to protect it with the IP65. And also we are here with the earlier those days, we were having a 10 kilowatt inverters, 50 kilowatt inverters. They were quite big in size, but now we can say that even 200 kilowatt of inverter and 250, 300 kilowatt of inverter, they are quite small in size. Yeah. They used to call it the central inverters. So we have seen a lot of changes in the solar industry, and particularly about, I'm talking about the inverters. Yes, it has been changed a lot. Now we are doing a lot of optimization thanks to the R&D team of the various industries. They are supporting us a lot. So here we will see in the near future, we are going to see big size inverters in central inverters and also in string inverters. Very soon, it means as a ceiling, I can say that very soon we are coming up with a new inverter. It is called a 320 kilowatt inverter in the string domain. And in the near future, we are going to see 6.25 megawatt central inverter. So this is how the industry evolved. Maybe in the near future, we are going to see changes in terms of DC voltage. Earlier, we saw in 2016, we saw 1000-volt technologies. Now we are witnessing 1500-volt technologies. Very soon, maybe 2023, we are going to observe 1800-volt or 2000-volt DC voltage, which would be a very good advantage for our IPP players and the EPC players in India, of course. Yes, Mr. Abilik, to you.
Yeah, Mr. Chaudhary, thank you very much giving this background. Yes, during last 40 years, what you are seeing most of, but incidentally in my laboratory it was very small this thing, and then 7.5 kilowatt was 10 by 10 room it was there, and now the size has come. Then the price has also come down. Today I was talking to one of the leading dealer of one leading solar inverters. So then the price is also, I think, around 2.5, 25 lakh per megawatt for this smaller one C&I section, and around 1.8, between 1.8 to means 18 lakh to 20 lakh rupees per megawatt for the project side. Or means if it is a larger solar parks, then maybe little good negotiated price. So all front, actually the good development has happened in during last 20 25 30 years, and in fact rapidly it has come to this after 2010. Rapidly the technology improved a lot. Now Mr. Suvir Karmakar has joined. Mr.
I think he has.
Mr. Now the next panelist is Mr. Suvir Karmakar, Deputy General Manager Engineering from NTPC. Mr. Karmakar. If he is not there, then I can call Mr. Ashutosh Singh, Head O&M ACME.
Yeah, hello sir.
Yeah, Ashutosh. Yeah, good evening.
Yeah, hi, good evening everyone. So I will start from some operational insights and challenge or the experience which we faced, and some insights for the OEMs as well to see the overall feedbacks or experience related with inverter from the operational point of view, because fundamentally those inverters need to be run for the entire year of the projects for 25 years, and on day to day we are the ones who have to tackle their performance generation, their trend with the GTP or the guaranteed terms of time and all. So as everybody has rightly said, that inverter technology in terms of their sizing, in terms of their capacity has changed a lot. I mean, it started earlier, we started with some decent sized ground mounted project with 500 kilowatt, 350 kilowatt, or let's say 1 megawatt of project capacity, where there is a 2 or 3 slots connected with some 60 cells or maybe thin film modules, and you have a decent configuration and having string level data and correlate with the inverter performance, string performance, and easily you can identify and check the performance of the plants related with inverter or maybe modules. But later on it get changed at both ends. At a higher end, we are having, let's say, 4 to 5 megawatt size central inverter also. At the same time, we have a 50 kilowatt string inverter also. So with it, and both have their own pros and cons, some challenges as well. So if we talk about the central inverter, where the capacity has increased drastically, we have 3.75 or 5 megawatt of a central inverter. Most of the inverter, if have a common bus bar, then it is very challenging to accommodate all DC section with the same inverter with the 30, 40, 50% of DC connectivity to ensure a similar level of performance across all the DC field, considering that fact that there will be some changes in terms of mismatch, in terms of cable length. And when these are connected with the central, that inverter, that means you are getting an output against the entire 5 megawatt or maybe 6 megawatt of the capacity. And at the same time, we have to correlate that output with the expected output, which we have simulated, let's say from the GTP of the supplier or from the O&D file provided by the supplier. And we have to make sure that the inverter is being delivered on the same level what it should be as per the GTP of that document, in terms of the inverter efficiency, in terms of the MPPT voltage range, in terms of the current what we are getting. So from a random point of view, sometimes we feel that there should be some from the supplier, we should get that support in terms of the expected output vis-a-vis the output which we are getting from the inverter. I mean, it is collective from the entire capacity which is connected from the field and expected based on that versus what we are getting. So that is one part. So that is one part of it, and mostly we usually get that support from the supplier. They try to simulate the output of the inverter. They share the generation data and the expected power and all. But since the measurement instrument being used inside the inverter have higher uncertainty, so it is, and the MPPT voltage or the current which we are getting from the inverter display, since these are the big inverter, it is not that easy to put some power analyzer or take the inverter input and output and ensure that how much we are getting in terms of the MPPT voltage, whether that is the maximum voltage which inverter should operate at that time. How much switching time it is actually taking while there is a radiance level variation in field, whether the voltage is being ramped up at the same level on that MPPT where it should be, where we simulate in a theory term. So these are the some challenge and will take some maintenance related aspect as well. So initially when inverters are under warranty or being supplied from the supplier, then maintenance activity is something where there is a routine plan, some activity as a random operator we have to do, and some activity the supplier recommends and they do in a quarterly basis or maybe in a half yearly basis. But post that initial 1 or 2 years, when we need extra care of those inverters, we should have a detailed maintenance plan, and vis-a-vis the correlation with the maintenance and the expected output also, like the inverter efficiency or the power trend. So those should be more aligned nowadays, because now all the projects mostly which were installed in 17, 18 or 16, they have now 5 to 6 years of operational experience. So with this 5 to 6 years of operational plants, we should have some more insights or details from the inverter suppliers, so that we can accordingly make a plan of the preventive maintenance, their activity and the routine of it, to avoid any failure or to maintain the expected output at the same level where it was earlier 5 years back, in terms of the IGBT, in terms of the capacitor, in terms of the electronics component. That is part 2. And the next part is, like I always thought, in terms of the inverter performance, we have to follow some sort of routine maintenance, and there will be some output. It start generating basis their MPPT range and the output range. But the failure, whenever there is a fault or failure, manually as a random operator, we have to go and check that fault. Need to check either it is related with field or maybe equipment, and you rectify it. And repeatedly, you have some sort of historical trend of the fault types, failure types, their list, and what kind of problems we identified, what was the causes of it. But from inverter sides, nowadays, since technology has grown up at a very high level, and you have all the technical data information, the insights, and other digital platform where you can use some sort of digital twinning and the data correlation. So now inverters should, we have to go in that direction where inverters should trigger alarms basis their insight parameters, that these are the parameter where we are facing some variation. There may be chances of breakdown, or this may equipment or component may fail. So that instead of doing a corrective and the reactive maintenance or solution, we can do some sort of predictive maintenance of those inverters. So that is also an insight where we should. So right now also that thing is happening. We are doing that thing with some separate analytical companies, or engaging with some sort of different digital companies which are taking the data from the inverter and doing some sort of analysis and all. But this thing should come from inverter supplier itself. Because they know their inverter in a better way and have all these insights, their characteristic, their equipment selection, their insights and everything. So that also a feedback from related with the future roadmap of the inverter in terms of more smart.
Yeah, thank you, Mr. Astos. So, well, yeah, your company is doing a good job. And of course, this O&M is a very, very important. And if O&M is not properly, then of course, the lot of output or means yield will be lost. So it is a very important, very much important that O&M is to be regularly done. So as per that depends upon the area to area also. So thank you very much for giving this your views on O&M of your company, and of course that apply to other companies also. So then can I call Mr. Karmakar now? I think he has joined. Mr. Karmakar, are you there? I think still he is not there. So next speaker is Mr. Sanjeev Jha, Head of Business and Operations, U Solar Clean Energy. Mr. Jha, over to you.
Hello everyone, good afternoon. This is Sanjeev from U Solar. First of all, I'd like to thank EQ for giving us the opportunity to speak and on the inverter. So basically, how do we select the inverter? So any manufacturer, we would like to understand, they have a manufacturing unit in India or not? Do they have a service in pan-India, or whenever there is a defect or any fault, how they can rectify, what is the downtime they can assure us, those kind of thing. And selecting an inverter is it depends on the location, and either it is a center. If we select a center inverter, it's quite difficult because any fault, any IGBT failure will create a bigger issue there, because transporting an inverter from the manufacturing, let's say a manufacturing unit in southern part of the city, and you are doing project in the north or the northeast, and you're putting a central inverter there, and any failure becomes a big issue, and there is an increase in the downtime. So we need to think, how do we select the inverter on the location wise plus size, so basically central inverters are larger in size, it's not portable. So and because of the delta in the pricing of the string versus central, we feel now string is getting a bigger market share, and is easy to install, and we don't need some control room, or you don't need any big foundation works to be done, and becomes easier for as a EPC company or as a developer to install the plant, and downtime is less. Those kind of benefits are there with the string inverters. And coming to the demand, we are facing some issue with the demand because of I think there is some shortage of the semiconductors, and but it's a temporary disruption in the market, but I think should get recover, and we'll have a bigger supply. And a lot of manufacturers, I think they are trying to open a manufacturing unit in India where they can supply the huge demand in the India, which they are going to come up in the next few years. Coming to the pricing, obviously India is a very price sensitive market, and central as a price, it's a bit of benefit, but we felt there is a bit of a concern because the pricing of the central string inverter coming down. We kind of preferring it to go to the string inverter rather than the central inverters. We, for last few years, what we experience is like there are a lot of failures on the central inverters compared to the string inverters. And yeah, it's string inverters now, I think it's coming up to 350 kilowatts. So we kind of more inclined to the string rather than the central inverters. Thank you. Over to you, Akhleshji. Thank you.
Hello. Yeah. Mr. Chaudhary, Arun Chaudhary.
Sir.
Yeah. So you can now present.
Yes, sir. I saw this as an opportunity. I would like to share one presentation of the company and the roadmap. Maybe this will give a more clarity.
Okay, fine, good.
Just a minute. Huh?
Yeah.
Mm. Is it visible, sir?
Yeah, it is visible very much.
Oh, thank you so much.
Yeah, you can continue.
Just now we hear a few words from Mr. Jha. So I want to just add into that there are certain developments which are going to contribute in the Indian market. So this is how Sinning has started its journey in India. We are not too old company for the India market. We started from 2012 as a Sinning in China market, and then we are in India since 2017. In 2018, in 2014, we have acquired a very good company called Immersion. Immersion was a very good company in the power electronics domain. They are very good in that. Then we have one other factory in China. In 2018, we have finally inaugurated our factory in India business. So from there, I will take it forward. In 2020, we got listed in the Shenzhen stock market. This is our financial figure, how we have grown as a whole, globally and also in India. So far, we have done business around 40 gigawatt of the market as a whole in the globally, and our revenue is not too much. It makes us very competitive for the India or for any other competitive market. Going further, these are the locations where we are working as of now, and we have a plan to work for most of the European market, also for the Canada, and we will cover most of the Africa market. It's all going to happen because we are very good in the R&D sector and in the developing new products as per the demand. So finally here, I want to show you my factories. The first one is in the Jiangsu, China. This is our head office. Another one, we recently have another factory in China. It's in Ningxia. This is our Indian factory. It is 10 gigawatt of factory. Earlier we had 3 gigawatt of factory in India. Now we have upgraded it to 10 gigawatt. This is the location. And this is the aesthetics, what you can refer from the online, and what you can see it here also. If I see about the Genki report 2022, we are top 2 in terms of central inverter, which is a Forte. We are number 1 supplier. In terms of the global network in India, though we came to India in 2017 and we start getting our installation from 2018, we have developed 6 gigawatt of the orders, and now more than 4 gigawatt is on the footprint. We have a manufacturing base in Bangalore. It is 10 gigawatt, and marketing center at the very location, and also the Bangalore location. We have 4 centers and more than 200 employees. This is a helpline number if someone is facing any problem or service-related issues. These are the major customers to which we are already working with. A few are from a Chinese company, and most of them are from the Indian companies with whom we are already working with. This is how I want to show this PPT for a very good reason. As the module is developing, same way the inverters are developing. As the module is shifting from the poly to the bifacial, the current rating is going to be shifted, and that's how the inverter needs to have this capability to accommodate those modules. And that's why this PPT is here. So here you can see the size now, which is more common, is 182 mm. Another one is 210 mm. This one, they are going to create a very good module for the IPPs and for the EPC players. They are going to be in a big size, 540, 550, even more than 600 watt peak. For that, the same module size is going to be used. And that's why what is going to be changed, the current rating for the inverters. I will show you next. You see, if I talk about the central inverters now, earlier the requirement was if you're going to use Y-clamp connectors, the 330 amperes was enough. But nowadays it is not sufficient if you want to use the 30 amperes. If you're going to have a bifacial module, it needs to be increased for the SCB boxes. And that's what the inverter need to have, that capability to accommodate such kind of SCB players. Similar way, we need to accommodate the short circuit current for the AC side. This is the upgrade which is required for any inverter. And here, this is the product. This product, I can believe this is the first of its kind in the India market, where we launched this product in 2018. Earlier to this, we were witnessing 1000 volt inverter, which was having container solution. And even for the 1500 volt solution, we saw many container solutions, many container solutions. And in the container solution, there was only one big problem. The problem was that once you open the door, the inverter, who is IP54, IP55, suddenly the moment you are going to open the door, it becomes IP21. And that was the problem, because for the IGBT and any for the electronics item, the dust and the moisture, this is the killing item of any inverter. So we understood this thing, and my immersion team, which is finally a sitting team now, they have developed a new model. It is perfectly outdoor inverter. This IP65. It can solve the problem which was related to the moisture environment or with the environment which have the dusty solution. This is the solution. So we come up with the outdoor solution. So this is the flagship product. We have sold many of such inverters in the India market, and it is really doing good, very good, very good. Coming to the string solution, string earlier we saw the word from Mr. Abhilak Singh. Earlier in the India market from 1996, we have only used string inverters. Those were very good, very big in size, so much noise. And also to maintain those inverters was quite tough. he must understand these things. He had witnessed those things. But nowadays, see how far we have come up. Now we have a 250 kilowatt of inverter for in the market, and also 275 kilowatt of inverter in the market. Such inverters was not available earlier. Here you can see we have multiple MPPTs, and also we have the phenomena that we can accommodate 40 amperes of a DC side current. It means we can accommodate big size module like bifacial module. We can correlate with these string inverter solutions. This is the thing which we had to adopt, and we finally have adopted. This is the requirement of the near future from 2023, 24. After that, we are going to see only such kind of big modules. Recently, we saw we have the module of 800 watt peak, like a module. So here a little more about for the industry. This we come up for the both sides of this thing. We have 182 and 210 such kind of things. So we can accommodate 275 kilowatt. The DC capacity of this string inverter at 50 degree is 225 kilowatt. It's good for India market. Now this is the journey how we started and where we have been now. Now we can see 275. I just wanted to put the slide for a few references for the market applications. This is how we are working. Sealing is very good in the power electronics. In the near future, like from the past 1.5 years, we are seeing the ease of the application requirement, the bidding structure, how the policy is going to be changed. They are very much into BESS solutions. So China, they are already doing it. European markets, they are already doing it, and we have supplied to those locations for the ESS solutions. This is all. Thank you very much for the panel and for the members who are listening to me, listening to my company. Is there anything I can add? You can ask many questions to me. Thank you, Mr. Abilak, for giving me this opportunity to show the future, how the inverters are going to change the market, how they are meeting up the demand of and matching the requirement of the new module technologies. Thank you, sir. Mr. Abilak, to you.
Yeah, thank you, Mr. Chaudhary, for nice presentation you made, and you made aware to our all audience. Now, next speaker, can I call Mr. Srinivas Popuri, Vice President, Group Quality, Greenco.
Good evening, sir.
Yeah, good evening.
So, I thank, first of all, I would like to thank EQ for giving me this opportunity to participate and speak on this forum. So we as Greenco, we are developers and we are into large scale utility. And for us, it is very, very important that our solar parks get the best inverters in the market. So actually, we already have installed central inverters as well as string inverters, and we have seen that the performance is like almost equivalent in both the things. Some of the things have got some advantages are there with the string inverters, and some of the advantages. We are going to install very, very large scale, ultra mega scale projects in solar, especially that one is coming up right now is our IREP in Kurnool in Andhra Pradesh, wherein we have recently poured the first concrete for the hydro project, and it is around 1680 megawatts of hydro, and along with it we are going to integrate wind and solar. Wind would be around 550 megawatts, and solar would be around 3000 megawatts. So this 3000 megawatts will come at one place. So this is a huge, and such kind of projects are in the pipeline. Another 7-8 projects are in pipeline. So we are looking for, we are doing a lot of study on the inverters, especially the string and the central inverters. And personally, if you ask me, the technology has improved a lot, and a lot of advancement has gone into these inverters. And for me, there is not much difference between a central inverter and a string inverter. Both have got their own advantages and disadvantages. So, but what I see is the testing is conducted on these inverters. So, being a quality guy, I would be looking at the reliability, quality, and the reliability of these inverters. And for me, maintaining or getting confidence on the reliability is more and more important. So we have, the IEC has got a lot of good standards which it has come, and they're in place. We are very much confident that if the manufacturer conforms to all these standards, we will be getting a very good and reliable quality product. But sometimes what happens, I take this forum to put my concerns that many string inverter manufacturers or the inverter manufacturers, I would say, they bargain a lot on the QAP, the quality assurance plan, which are there. We generally follow these IEC and IE standards for these tests, but some of the inverter manufacturers, they negotiate a lot on these, especially tests such as heat run tests. That is one of the thing which comes as a type test and also a regular routine test. But the manufacturers generally they don't agree for this. So which brings a lot of doubt in our mind as to why the manufacturer doesn't agree for this. Some of the other things which I feel very difficult for the suppliers or the manufacturers to get agreed is the some of the insulation resistance measurements between inverter circuit and earth, or between control circuit and earth and electronic circuit and earth. So these are few things which are very important for looking into the quality and as well as the reliability of the inverters, wherein we are looking for inverters which has to sustain for the lifetime of the project along with the solar panels for about 25 to 30 years. So these are very, very important for us to see. One of the other concern what we have is the grounding impedance at the DC input cabinet or the main cabinet or the AC output cabinet. So these are some of the things which generally the manufacturers they negotiate a lot for doing these tests. So they may agree for a random ones, but we require more tests for maintaining or for having that confidence in the product. So similarly, there are a few more things like the grid protection function we would like to see, and the grid protection function test being done at maybe grid over voltage or the grid under voltage. So during these various scenarios, we would like to see how the inverter performs, and then also it is like one of the important thing, especially when we are having such large scale utilities, is the synchronization of the grid and the solar farm. So we would also like to see these test synchronization, like what is the frequency difference, what is the voltage difference, or what is the phase angle difference between the grid and our solar park. So we would always want to see these things in testing. So as I told you, the standards are there for us to follow, and they are well established, and which brings a lot of confidence in us if the manufacturer is following. But we also would, since we are putting up these large projects, we want to be absolutely sure how these inverters work. So we would see by ourselves how these inverters are complied with the standard requirements. Thank you.
Mr. Srinivas. Being from the inverter side, I clearly understand what is your pain point. Seriously, this heat on test is a very important parameter, and it had to be performed, what I can say. Eventually, because recently the manufacturers, those developing factories in India, they might not have this facility. But as a Cine, we do have this facility from 2018. I can say, because the Indian atmosphere where we are going to install these inverters, they are nearby to 50 degrees centigrade. So it is required to the inverter to be tested at 50 degrees centigrade. And that's how we'll come to know whether inverters are performing or not performing. So it becomes a very important parameter. So maybe you can ask your partner to develop that facility and get it tested. Given opportunity, Sining already have, maybe other ones, they must be in the development phase for sure.
Absolutely. See, you have got a good point. See, when we are encouraging make in India, and so we should always have whatever facilities that are there in our foreign countries, especially if you say it is China or any other country where we have got a lot of facilities for testing. The same should be developed here, so that as a developer, as an end user, I am absolutely sure about the quality and as well as the reliability of the inverter. So yes, as I rightly said, all the manufacturers who are putting up their manufacturing units in India should have all the facilities of testing to give us confidence.
It is required, sir, because ultimately the end user who's having the most of the responsibilities to pay in terms of revenues. So as a partner, we also have the responsibilities to support you that you have made a right choice. This is my intention. So maybe in near future, you will see that your partners, they also have this facility. I'm not sure why they couldn't offer you presently. If you're talking about the Cine, on the time of 2018, we didn't have any order, but even on that time, we had this facility. This is our chairman requirement. He really wanted to facilitate everything for the Indian market.
Right, that's good to hear.
Thank you.
Yes, Arun, we are starting the final discussion also. This is Chaudhary. So are you starting the final discussion or it is over? I joined late, sorry.
Sorry, sir. Over to you, sir. I was just discussion with Mr. Srinivas.
Over to you. What is that discussion? What is that agenda? Who is the moderator?
Mr. Abhilash.
Yeah. Thank you, Mr. Srinivas. So I actually this in between discussion anyway, that is also good, that should happen also. So can I call next panelist, Mr. Sarvesh Singh, head SCM Azure Power. Mr. Sarvesh Singh, over to you.
Hi, good afternoon, Dr. Abhilakji and all the panelists. It was nice seeing you after a long time.
Yeah,
Your erudite age.
we have been together working almost 7-8 years.
Yeah. So, thank you for giving this opportunity to interact on the inverters. You know, we have a large base of installation. We have approximately 3 gigawatt of installed capacity in our projects, and mostly it was central inverters. Now we have, in last year, we have installed approximately 900 megawatt of string inverters out of 1200 megawatt installed capacity in last 2 years. What we have done, when we have decided to move on from central to string, there was 2-3 specific reasons to take a call, because the delta price of the string inverter was higher than the benefits we were getting from the string inverters in the terms of costing. However, due to when we have discussed, there were certain benefits going ahead with the string inverters, like efficiency losses and other things, and ease of installation. In case of central inverter, once there is a fault, you lose large capacity for generation, whereas in case of string inverters, it's a smaller capacity, say 200 kilowatts what capacity we have installed for a particular inverters, and the replacement time is also quite less. And as Abhilakji and others have pointed out, that although cost of inverter in the total project cost is approximately 3 to 4%, but it's basically heart of the solar system. And the efficiency and performance of inverters largely reflect in your generation numbers as well as your revenue. So accordingly, we took a call and we have gone ahead with the string inverters. Although we are facing certain issues in the string inverter also, when we have installed. In the case of inverters, there are certain clipping losses with like if you are operating at more than certain capacity, design capacity, the inverters get tripped and certain strings are not working. So our team has interacted with the suppliers, and we are trying to figure out the major challenges what we face. Basically, this is the differentiation between central and string. My concern is that going forward after 5 years, when there might be certain, we have seen in past, like few inverter suppliers has abandoned their capacities and closed their capacities in India, and change from the voltage level from 1000 from 1000 volt to 1500 volt. When we now when there is an issue in a 1000 volt inverter, you don't have any option to change the inverters. In case of central inverters, you have to do, if you are wanted to change from central to string, entire cabling and everything needs to be done. So it's a big concern. And when we in one of our projects, we thought that is the issue. We did a cost benefit analysis that whether we should change with the string inverters or with central inverters. So finally we have decided, let us change to string inverter, because going forward, if there is any issue again, then getting that 1000 volt system today we can get, but after say 4 or 5 years, we may not get the those kind of inverters, central inverters. So this is the major challenge what we as a developer we face. In all those issues of the quality installation that we can manage during the installation phase, but during O&M phase of say because the projects have a life cycle of 25 years, and these inverters, most of the inverter suppliers are offering for say 10 years warranty in case on the basis of certain commercial addition. So even after 10 years, when you need to change, in case of string inverter, you can change the inverters. It will be an easier task than changing a central inverter. This is one big reason what we have found, that let us go ahead with the string inverters. However, from the cost perspective and LCOE, since we have seen in last 2-3 years, or say since last 2014-15, when we have started solar business. In fact, personally, I have started solar business since 2014. The prices has come down significantly, and it is say when it was in the range of 35-40 lakhs per megawatt. Now it's maybe in the range of for central inverter maybe 10-12 lakhs per megawatt, and for the string maybe 14 to 15 lakhs per megawatt for string inverters. So delta has reduced significantly from center to sting, whereas LCO is, or you can say it's a comparable if you can optimize the other balance of system with sting inverters. So it's a better deal to go ahead with sting inverters. You will have certain benefits in generation as well as and ease of maintenance will be also there for sting inverters. So these are the basic takeaway from our side from the inverter perspective. Although since last couple of earlier it was a downward pricing, now the inverters manufacturers also putting up the facility in India and they are asking higher prices because due to the change in commodity prices. We are discussing and we hope that the prices will remain in the reasonable level and we can go ahead with the suppliers for sting inverters. So this is a brief input from my side. Abhilakji, over to you.
So thank you, Mr. Sarvesh Singh ji, for your good presentation. So I was not aware that you have joined actually Azure Power. So
it's 3 years. I have joined in October.
3 years.
3 years. So we built around basically 2000 megawatt in last 3 years.
No, that I am aware actually. I don't know whether he is still continuing your that CFO.
He's there. I think he's there. Mr. Gupta is there. Yes.
Yeah. So I have been, I think, in touch with him. And last time we organized one webinar for the Solar Energy Society, of which I am treasurer also. So then I invited him.
Okay.
Good to know, thank you.
Good to know, sir. Thank you.
Thank you. So now, now I can call Mr. Sudhir Pathak, or not Sudhir Pathak, Mr. C. Chaudhary, Chief Operating Officer, AMP Energy India.
Yeah.
Mr. Chaudhary.
Yes. Yeah. So what is the specific, you have any specific question or shall I speak, what is your, do you have any specific agenda for me or shall I speak myself?
Yeah, you can speak please, Mr. Chaudhary.
Hello?
Yeah, Mr. Chaudhary.
Yeah, so I am saying you have any specific agenda or shall I speak?
No, you can speak. You can speak on your own. There is no specific.
Okay. So, just give me 1 second.
Yeah.
So I think in the I think we have seen the webinar core is related to the demand supply technology and the pricing part, right? So definitely I can say the technology wise, let's go one by one. Inverter technology wise, definitely the technology improvement is happened last 5 years drastically because people have gone up to 5 megawatt in the central and the string people have gone into 250 kilowatt, right? From 90 to 250 kilowatt has gone into the string inverter, and around 3.125 which we are using past few year or 1.25 we are using past few year, now it's gone to 5 megawatt. The similar case like in the pricing also, pricing has been dropped significantly. I do remember because in 2010 when we are buying the inverter, the prices was around 60 lakh, 70 lakh. Now it's gone around 10 to 11, 12 lakh, something like that. It's not the exact figure, roughly as 9 to 12 lakh you can consider. So there is a definitely there is a price reduction is happened, and this is happened for both utility and the CNI business because demand in the India is a very high in this case because most of the people they are moving to reduce the capex because of there is a high pressure on the tariff side because our tariff is not very high, but we have to make the good return in that circumstances, right? The price is still we are looking further drop down, and the inverter guys to have also bring the better technology where we can get the uptime guarantee higher, and warranty and guarantee should be also we are expecting some better performance from the all the manufacturer. Definitely, there are a lot of manufacturer already enter into the India business in the Indian segment, and they are drastically reducing the price, and they are making make in India prospect also, because when we talk about the ceiling also, they have also manufacturing location. If I remember in Bangalore, right? So while getting the inverter from India, definitely you can reduce some of the duty and other benefit, because in the current scenario there is a tremendous pressure for the COVID wave 4 is happen, and lot of shipment was stuck in the China, due to which we are not able to commission the project on time due to the shipment, because they are also totally depend upon the other local manufacturer, because they are manufacturing and assembling, but the part like IGBT and other component they have to take from the other vendor from their subcontinent. So that has been delayed. So better I always urge people have to come invest in India for particularly in the inverter and module side, so that we have to get the extra benefit. We have to reduce the timeline so that we can remove the avoidance of the commissioning timeline. So most of the I think manufacturers they have already opened, and they are doing pretty well. But the pricing part also, I think the price is currently it is stable. But we request all the inverter guys to they have to reduce the further prices, because our tariff is a bit low and the commodity prices is going up for the structure and module side also. So we need support from this part also. More important is that the inverter guys had to bring the technology and compatibility as the module manufacturer they are making in the different technology. Suppose initially it was 440, 335, 440. Now people have used for 540. Now we are talking about the 600 plus P type or N type of bifacial. When the technology will go from 544, 650 or 700, definitely the current and the current and the voltage will definitely will change. And the currently we are getting the current ampere for the inverter, and voltage is from 1300, 1400, 1500, something like that. And the current is expecting 13 to 12 ampere, right? But over the period of the time when the wattage of the module will increase like 650 or 700, the current requirement is like 20-30 ampere, right? MPPT range should be higher. So inverter guys have to wait and watch and take the necessary action, and they have to coordinate with the manufacturer. They can see the trend, how the market is behaving, how the technology, because it is a totally correlated, or we can say directly proportional to the module and panel, because the panel inverter cannot do the independent. They have to go on the basis of their compatibility for two, one of the module, and second one is the IDT, right? So they have to check how the IDT transformer guys is moving, what is their input and output range would be their similar case in the module, what is the MPPT range they are looking, what is their input, what is their output, what is their current, what is the voltage. Accordingly, they have to make the compatibility, and they have to move fast as module manufacturer is moving, not only for the pricing. This is the technology is very other part of that. I heard from also that the other manufacturer they are going for 2000 of BTC of the inverter. So I urge all the manufacturer they have to go in that domain, so that we can make more overloading, reduce the cost, and increase the performance and loading in our system. So that transformation we are looking ahead from the inverter manufacturer. While coming into the train, because most of the people are moving from central to string also, so I also suggest manufacturer, if you are doing only for the central, better slightly your focus 50% or 6, that is their business decision, but this is my recommendation. At least they have to focus some part of the string side also, because if the trend will go into that direction, they have to pick up and go in that direction only, because it totally depend, the market is totally driven by the investor and IPP, and the manufacturer have to go. Definitely the other part we are looking from the service and maintenance part, because in India our plant is a different location, And one of the plant we are putting like 250 megawatt of the inverter for the 12.5 megawatt of the block. So number of inverter will be increased in this case for the different location. And suppose some failure will be happen, so their field service engineer should be available for the all region 24/7, so that our downtime can be minimized and our losses should not be occur, revenue should not be occur in a huge penalty base. The third one, what I occurred in the operation and maintenance from the inverter side, they have to make the central inventory system in India, and they have to put at least the spare part for all the equipment. So whenever we are getting some of the problem, they have to come and rectify. They should not depend upon, they have to bring from either China or the other part of southern part of the location. They have to make the specific location by the inventory so that customers should be not focused. So my not only worried about how the technology is pricing, they have after installation during the operation, they have to also focus on how they are going to support to the customer in the different angle, and that the customer should be, go well. I mean, I have at least experience with the sinning. There are at least they're okay. The service part is very, very good. They are excellent. They are going and doing all the work. So that part is okay. But for all the manufacturers, those who don't have the field service engineer, they have to come up and they have to go in the field, make the inventory system so that people have to go and implement that. The rest of the other technology, if they are coming, they have to show the roadmap. They have to bring with this also what the R&D they are doing and when it is expected to come into the commercial stage. That is from my side, Mr. Avila. Yes, over to you, Mr. Sin Saab. So over to you.
ठीक है, it is okay, Mr. Chaudhary. I think you made a good presentation and you put forward your views. I think it is a good. And now I can call Mr. Pathak, Central Design and Engineering and QA at Hero Future Energy. Mr. Pathak.
Yeah, thank you. I hope I am audible.
Yes.
Yeah. Good evening to all. So actually, the solar business, what I perceive as of now, when I say solar business, only solar kind of plants. As of now, they have become total commodity business because you can see now, and when anything becomes commodity, that means since you have a lot of manufacturers on board, and you have a lot of choices to pick and choose. So fundamentally, it has become a commodity business, wherein still it's a combo, wherein like the module technologies are still moving up. So like other co-panelists told that the module size and module rating from poly, and then gradually it became mono PERC, and now in future it become heterojunction, and HJTs will come into fore. Maybe perovskite will come. So so fundamentally, like modules, as I always keep on saying, that they are basically the heart of the plant, and inverter is basically brain of the plant, and remaining things are different, you can say, limbs of the human being. So the brain should always be equipped, whether it's aging or it is new. So it has to always to be able to control the complete system to make your body healthy. So from that perspective, if what I perceive, I will try to take this discussion, what we are presented today, what are the challenges, and what is going to be the technology in the future. So presently, we are here where, like now it's an age-old debate whether string inverter is good or central is good. Lot many webinars have happened on this, and wherein we have debated if undulations go with the string inverters, a lot of bigger size, floating over central, or if it is a plain vanilla or kind of flat terrain. So now fundamentally that is not a debate, because and also the cost pricing is coming very near, and the advantage what we have with the string inverter is humongous as compared to the central one. The only challenge is in this commodity date, number one, that obsolescence. First of all, it is commodity. Second thing is that still the technology of the modules are changing. 1000 volt to 1500, maybe tomorrow it will be 2000 volt. Even the modules itself is changing. So whether my today's inverter is suitable for tomorrow, like we ourselves faced this issue with one of the central inverters. We were scouting for the people who can provide us the inverter retrofit for the 1000 volt system. Nobody was there. We found only one, and so that was a kind of that became the supplier market. So that is one of the fundamental things. Second thing is MTTR and MTBF, mean time to repair and mean time between failures. This is a fundamental issue which is going to happen even from the operations perspective, because if so, whenever we tie up with any inverter manufacturer, they should ensure that they keep things in stock. They have their services in the vicinity of the plants so that they can immediately repair. They keep their stock even if they are going to make it obsolete, they keep it, those important stocks for the future. This is as far as the running assets are concerned. But what I perceive as we move ahead, the market will never be like this, because solar is going to change its shape, size, like a solar wind hybrid, which is already happening. Storage, it will combine with the storage, it will combine with green hydrogen. So from that perspective, now inverters have to be adaptable from that, from storage perspective. There should be a fleet of inverters which are hybrid type, which can even seamlessly connect to the battery systems, which are there, which are coming up. Regarding the green hydrogen part, what I perceive that since the electrolyzers are DC inputs, so we will gradually see a lot of DC to DC converters will come into the picture, where we can directly connect to the electrolyzers from the solar modules. One very important part which I want to connect it from the telecom industry. We can see that now we are moving towards 5G and then towards 6G. Right now we are with 4G, we have 20 Mbps or 25 or 30 Mbps of speed. With 5G, it is going to be 20 Gbps, which is 1,000 times more, right? Second thing, if you see the progress in our solar industry, so our sizes are now the plot size, the complete plant size are now minimum 250, it goes 300, even 600, even 1,000 megawatt. That means huge number of huge area, lot many components. It is humanly not possible to basically analyze, troubleshoot. With this kind of competitive market where we win the tenders at very low tariff, so our revenue depends upon the future, upon the operations. So fundamentally, if we are very smart in operating, how can we become smart? If we digitalize our complete system. That means now the future is going to come when we have to create each and every component as a digital twin, as an IoT. So what I perceive as of now, whatever components we can digitalize, we can be a smarter operator, and then we can provide the expected revenue what we have designed for to our kitty, which will make us sustainable. So from that perspective, what I perceive that as of now, what I see that string inverters, they are fundamentally working as an IoT. They have the capability building up into artificial intelligence, where they can go up to the module level even and tell which particular module or at least string is not performing and why. So the world is moving even beyond predictive maintenance. It is going to the prescriptive maintenance, wherein we need to create through artificial intelligence and machine learning the digital twins, where sitting in even work from home or even from the office, we can find out which particular module at what point of time or which particular stream at what point of time is not operating in the way it should have operated. So in my opinion, the future is that. So the technology, whosoever is making the inverters or whosoever is making the things or designing the whole system, integrating like us, so we should think from that perspective, and that is going to go to the future. So in order to summarize, I can say that yes, it is really a commodity market as far as solar plant is concerned. There will be a real problem in the near future of obsolescence, where we need to devise a mechanism, maybe all the developers here, we need to devise a central pool of system where we can create and use it for the future, because we are now displacing oil and bringing electrical energy and plus hydrogen for decarbonizing, which is going to be the future, or you can say that will be a future of India or the globe, the energy security, what we preciously say. It is a very important onus. We should try to move in that direction and try to secure our energy by ensuring that we are ready for also all those obsolescence, we're ready for new technology, and we are digitalizing the complete ecosystem. So that's a take from me. Thank you.
So thank you, Mr. Pathak. You have made a very nice presentation, and you have put forth your views on this inverter technologies, pricing, etc. So now I can call Mr. Sanjay Singh, lead design at BBG Clean Energy Limited. Mr. Sanjay Singh.
Yeah, very good afternoon, sir. I am audible, sir?
Yeah.
Yeah, first of all, I would like to thank EQ for arranging this webinar on an interesting topic, sir, and like this, and also I would like to thank all of my co-panelists who are presenting their wonderful views. So to make this webinar more interesting and resourceful, I will share my views on the topic via brief PPT. So can you allow me, sir?
Yeah, definitely. Yes.
So my screen is visible, sir, basically.
Yes, sir.
Demand of inverter for the Indian solar industry, sir. So as whole world is moving towards net zero emissions, sir, and reduce the global temperature 2 degrees Celsius. As we all know, the India is growing economics, sir, and it is hard to us to move completely towards the renewable. Even our Prime Minister, Mr. Modi, has set an ambitious target for India to achieve this target by 2050, sir. So need another 10 years to decarbonize India economics and depend on the fossil fuel. So that it is a very important topic, demand inverter for Indian solar industry, sir. So basically current inverter demand in India solar industries. So if I'm talking about the global inverter market is projected to grow from 12.8 billions to in 2020. 2 years to 26.5 billion by 2025, sir. It is expected to grow at a CGR rate of 15.6 from 2020 to 2025, sir. So there are the 5 to 6 major factors that driving the demand of for inverter in India. Just like India is the 4th largest producer of electricity in the world, sir, and has witnessed as the transformational change in the energy sector with the supportive policies and intervention as well as the sector reforms. And the government initiative such as the smart city projects, the development of the solar parks, green hydrogen projects, and solar energy subsidies scheme would be further escalate the adoption of the solar installation across the residential and as well as the commercial segment. So, and also the demand of the electricity in India is increasing due to the shortage of the coal. Because of this, so many companies and also government are investment in this sector. So the demand of inverter as well as the micro inverter or off-grid inverters is increasing, basically. Rising and awareness is the more important factor for the demand of inverters. The growing participant of residential and commercial segment towards the solar system. So these are the important factor for Indian solar industries. So moving further. Inverter demand growth. If I'm talking about the Indian solar market size projected to grow across 14.4 during the financial years 2020-25. Basically, as you can see my screen, Asia in Asia maps, Asia Pacific records highest market growth in renewable energy sector. Asia Pacific garnered the highest share in the solar inverter market in 2020 and 2021. In terms of the revenue, and is anticipated to maintain its dominance during the forecast periods. This is the attribute to the presence of key players and high consumer base in this region. And Asia is also expected to be fastest growing market for inverter, as currently many countries such as China, Japan, India, and Australia are striving to boost their solar PV installation capacity through the advanced solar PV system that could be in turn enhance electricity stability. That's why inverter demand increasing in India and also price go up, basically. So these slides to say how to demand is increasing in India, basically. So in an Asia region, basically. If we are talking about supply of inverter or technology of inverter, so market is dominated by few major players, basically by product wise, by technology wise. If we are talking about product type, the central inverter segment held the highest market share of about 50.9% in 2020, and is expected to maintain its dominance during the forecast period. This is mainly due to rise demand of central inverter for large industrial and utility application across the globe. So, if I'm talking about the central inverter manufacturer, so then there are the 5 major key players in the market, that Siemens, Sungrow, Femer, and TMEC. So as you can see on my screens, obviously. In the same way, if I am talking about distributed segment or string inverter, in this also few major players, that just Sungrow, Siemens, Femer. So it is also important factor for our solar project. There is a few inverter manufacturer in our segment. So if we are talking about the price, inverter price, so price is the most important determinant of the demand and supply. The law of supply and demand indicate that if the cost of a particular product rise, demand will decrease. There are the 3 and 4 major factors causing the price rise in India. Due to the rising demand of the inverter, the price is rising. And also the second factor is the import duty of solar inverter also increased by the 15%. So the cost of inverter also increased by 10 to 15%. Third one is the GST. GST is the hike from 5% to 12%, which makes the solar project unviable in India. So that is also an important factor for our solar project. If I'm talking about the Indian manufacturing of an inverter in India is also increasing by 2030 due to the increase in the metal cost and also semiconductor cost. Also due to the shortage in semiconductor production of inverter, also hampered due to the shortage, also product cost increase. So moving way forward, as the solar industry is not expecting any reduction in the price in the next 8 to 10 months. So one of the reduced price increasing is by adopting better technology available today. Now we have better module and inverter. As Chotu Chaudhary sir said, that technology important factor for our project for our solar project. So now we have better module and inverter, which will bring down the our BOS cost or levelized cost of electricity. On another side, if I'm talking about the government wants to promote solar, and on other hand, price are increasing drastically. To promote solar and renewable energy, central or state government should have waive off GST at least for the commercial and as well as the residential sectors. So the way we have given the relaxation in the registration and stamp duty for the real estate sector. So in this way we can reduce our price or also in our solar project cost. So technology value engineering is a very important factor for the reduce our BOS cost and as well as the project cost. The technology advancement mostly from 3000 volt system will added value once it comes in the market, and value engineering is important for the highest watt peak module and inverter higher MPPTs. These kind of a small value engineering lead to cost optimization, just like operational excellence by reducing the operation and maintenance expense and faster project execution. So these are the technology wise, and going forward, corporates looking to adopt solar power have a lot to be excited about as a technology evolves further. given the advent and rapid development for the artificial intelligence, and machine will be become more efficient and intelligent, and will help in escalating the growth of the solar industries. So, with this above point, I would like to conclude my views on this topic. Thank you everyone.
Abhilak sir.
Yeah, thank you, Mr. Sanjay Singh, for nice presentation and your views on this inverter technology, pricing, etc.
Yeah, thank you, sir.
Yeah. So now Mr. Arun Chaudhary from NTPC has joined. Not Arun
Sir,
Chaudhary, Mr.
Subir
Karmakar.
Subir Karmakar, sir. Yeah.
Sorry. Mr. Subir Karmakar has joined this webinar. So now I invite him for speaking on this topic webinar. Mr. Karmakar.
Yes, sir.
Yeah.
I'm sharing my screen, sir.
Yeah.
Sir, is it visible, sir?
Yeah, yes, it is very much visible.
So, sir, I'm covering the topic related to, sir, inverter technology, and so basically the solar inverter are the interface between the DC PV array and the AC grid, and it has many responsibility. One responsibility is to operate the PV at maximum power point, because PV is having a parabolic kind of graph that vary with respect to the irradiance and it is temperature. And in the grid side also, it required to operate the solar plant in compliance with the grid variation in the voltage and frequency, and generate active and reactive power based on active power based on the solar radiation, and reactive power based on the grid requirement. So so the one responsibility that I'm mentioning, that responsibility is to operate the PV plant under PV plant at maximum power point. And this PV graph is vary. In the left side, it is a variation is with respect to solar irradiance, and as the solar irradiance change, the maximum power point is also changed. So based on this, if there is any solar radiation change, then it will operate the PV system under different voltage DC voltage, so that the maximum power can be extracted from the PV energy, PV system. Similarly, if the temperature of the module vary, then also the graph of the also change. So again, it will operate at different voltage in order to optimize the generation. So in the inverter, this inverter generally in the earlier, maybe in the 2016 and later, that we generally use a two-level inverter. So the two-level inverter is basically a 6-device configuration, and these inverter are generally of 1000 volt DC application. So initially we have 1000 volt PV system, and inverter DC voltage is 1000 volt maximum, and rating of the inverter was in the range of 1 megawatt to 1.25 megawatt. So in this two-level inverter, this actually convert the DC voltage into the AC voltage. So the simple conversion possible with the square wave kind of waveform, and that shows in the left side bottom, and this is a square wave kind of thing. So with this kind of wave shape, the output voltage have a different harmonic component, and these harmonic component are like 5th, 7th, 9th are the dominated, and due to high harmonic contact, the THD value of the voltage will be of around 30%, 26 to 30%. So in order to reduce the harmonic content in the output voltage waveform, generally we do with pulse width modulation, by the pulse of the waveform is chopped multiple times in order to generate a weighted sine wave kind of thing. So initially we chop the width of the pulse will be very less, and gradually at the center it will be high. Pulse of the means pulse width will be high. So the weighted value will be like a sine wave. So with this kind of modulation, we generally reduce, means we generally eliminate the lower order harmonic, and the minimum harmonic that comes at equivalent to it is switching frequency. So as the harmonic content lower level will get eliminated and it shifted to the higher level, so with a very nominal filter requirement, filter like LC filter of very nominal capacity, and the transformer impedance itself will be able to filter it out further. So the final at the grid current connection point, it will have a very less harmonic content in terms of voltage and as well as in current. So initially the topology was 2-level, and it is because of also because initially the module maximum DC capacity, DC voltage rated is around 1000 volt, and generally this IGBT devices come with 600 volt rating. So two devices are generally sufficient to having a 2-level topology. So both on the module side, we have a limitation of 1000 volt, and the inverter side also, because of the IGBT rating, the 2-level configuration are at this time are very suitable. Then after 2016 onward, I think that we shifted to 1500 volt topology. So in the 15,000 volt topology, we generally required 4 numbers of device, because 600, one device is a 600, so we need to connect a 4 device so that the 1500 volt can be means it can withstand. So with four device in series, that suitable topology is the 3-level topology. So we start from 2-level. 2-level means in the voltage waveform we have a 0 and 1. So that's why it is a 2-level. In the 3-level topology, we have a 3-step like 0, 1 and 2. So with this configuration, because of 1500 volt, we generally we have a level is also, means we have a 3-level. So there is an additional level. So that additional level also reduce the harmonic content itself, it will reduce, and further over that we also do the pulse width modulation, so that also reduce the harmonic content. But since as the level is increased, so that help reduce of certain lower order harmonic. So this pulse modulation that can be optimized, means the switching frequency in case of 2-level maybe it was 5 kilohertz, but with 3-level the switching frequency is reduced to say 2 kilohertz. So the switching losses in the IGBT and the converter will reduce. So that also give a additional efficiency advantage. Around 97%, 96, 97% is the range in the 2-level 1 megawatt or 1.25 megawatt inverter. When we switch to 3-level conversion, the efficiency was increased to around 98 or 90. Now manufacturer offering 98% efficiency, and that is possible only with because of this 3-level topology. Level would give advantage of reduction in the efficiency. Additionally, that since we connect a 4 numbers of IGBT, so the capacity of the inverter also increased. So now the inverter is ranging from 2.5 megawatt to around now market is available 5 megawatt. So with 3-level, the harmonic content also reduced, switching losses reduced, efficiency increased, and capacity also increased. Then this is a 5-level converted topology. So again, because of level, means level is increased, those you can see that number of pulses, means switching frequency again further reduced. So with increase in level, the switching frequency can be further reduced and it will be improve the efficiency of the converter. Maybe with 2000 volt DC subsystem, maybe we'll going to have a 5-level topology. So as of now, there is no 5-level topology in the market. Mainly it is a 3-level topology only used. But this waveform is for showing that with increase in level, the waveform tend to achieve a sinusoidal waveform because of leveling. So in case of central inverter, we have a two topology. One is a single MPPT topology. In this case, the inverter modules are connected in parallel. Both DC side and AC side are parallel. So in the DC side, since it is a parallel connection, so all the PV will also get parallel. So since inverter operate the PV at a voltage, so since DC is connected with DC is common, so the MPPT is also will be a common, so it will be a single MPPT configuration. Then another, so this was the configuration the most of the manufacturer was offering. Now they itself shift to multi-level central inverter topology. In case of single MPPT configuration is that since the multiple modules are connected both side DC and AC side parallel, so there will be always some circulating current among the not circulating current, but there will be a in proportional sharing of current because of parallel impedance. So current sharing will be different, and for that additional margin also required. So, and additionally, since we are connecting all the PV at the DC side, so the DC short circuit current also getting increased, so that also finding difficult to handle or difficult to increase the converter capacity. So now the most of the manufacturers are now shifted to multi MPPT configuration, where the each converter module is having independent PV system, and they are providing, in this case it is a 4 MPPT solution. So the PV system is means split to 1.25 equivalent, and so each converter will operate the PV connected at its terminal at different MPPT voltage level. So the generation also will get optimized. But in this case also, it is not a very true kind of MPPT. The MPPT range among the converter is limited to say 50 volt. Means say PV1 is some voltage and the other PV having some other voltage, operating voltage, but the voltage difference will again limited to at around 50 volt. So in this configuration, there are two difficulty again. One is a circulating current among the converter at the AC side as well as from the PV side also there will be some circulating current. So that circulating current actually the reason for limiting the PV array to operate not a wide range of voltage, and that cap is there 50-60 volt, so that the circulating current is limited. Then another converter configuration, now it is not in commercial, any project is not there, but some of the manufacturer is having this, I think Sining is having this converter configuration. They have some pilot project also. So in this case, it is similar to string inverter, but it is distributed. Means this DC converter will be distributed. It will be in the place of SMB. In place of SMB, there will be a DC-DC converter. So the PV will be connected to this DC. So in the field, we have a DC-DC converter of multiple numbers. So this will be, means DC-DC converter will operate the PV at its maximum power point, and it will be a true kind of multi-MPPT configuration. And then in this DC-DC converter output is again get parallel at a central inverter. So this will again convert DC to AC. So this configuration, I think, will maybe in the future this configuration will come, because now the central inverter people are shifting to string inverter. but because of the size limitation in the string inverter, still the central inverter is preferred. But with this configuration means at the field side, if you have a MPPT DC-DC converter, and the central side means at the main common point we have a central inverter. So this will be having a both the advantage of central inverter as well as for the string inverter. Means field side you have a maximum power point tracking, and you have a common a converter, so that block size also you can increase. Similarly, this is in the previous one, it will be the DC-DC will be distributed along the field, but in the string inverter, the DC-DC and the converter will be part of the single panel, and the capacity is also limited to, I think it is around 200 to 300 kilowatt. And since we are having a DC-DC, multiple DC-DC converter, so the realization also will be better. So again, so this is the control of central inverter. So it required to control in the PV side, like maximum power point taking, and the grid side, it required to control active power, reactive power. Then different grid compliance requirement like HVRT, LVRT, frequency response, NTI leaning. And in the top, I mentioned the MPPT range. So now typically it is 900 volt to 1300 volt is the typical figure. In the AC side, AC output voltage is around 600 to 660 volt. So this is one important point. The lower MPPT range is a very important point, because this 1500 volt, initially it was a 900 volt. Now the manufacturer are shifting this 900 volt to near 2000 volt. So the advantage they are getting, they are able to increase the AC voltage. So by doing that with the same converter, they are able to increase the converter capacity. Say if the converter with 900 volt come with 2.5 megawatt, if they increase it to 1000 megawatt, then the capacity of the converter, same converter will increase without any much addition of any component. It will increase to say like 10 to 15%. So they are now doing all these things. As a developer, you should be very careful, and a proper study also required. Let's say in the area of Rajasthan, where temperature is very high, average temperature throughout the year is high. So the PV side will always have a lesser voltage. It will generate lesser voltage. So always there is a chance that this 900, or maybe it will be less than 900 volt also. So if you select any converter with say 1100 volt, then it will be limited to at 1100 minimum. It will cap at 1000 volt, and the PV will not operate at its maximum power point, because MPPT point may be at 900 or 920. So there will be loss in generation also. So this point also we need to keep in very. But if the project location where the temperature is not so high, so there the higher MPPT range can be used. But lower one, 900, initially it was 900. Now most of the manufacturers are offering around 960, in the range of 960 to around 1100 volt, 1000 volt, 900 to 960 to 1000 volt. So they are increasing. By increasing, they are getting benefit. Developers are not getting benefit with this. Lower MPPT range will always be beneficial, because inverter will walk up earlier and also shut down very later stage. So you have a better operating range. So thank you. With this concluding.
So thank you, Mr. Karmakar, making your good presentation on this inverter technology.
Thank you, sir.
So the host has asked you to start your video. So what is happening? This video is not coming. Anyway, So now another 10 minutes are there. So that anybody has questions to the panelists, I think they can ask. So now floor is open for questions to panelists.
So, Mr. Avilak sir, I will take this as an opportunity because Mr. Chaudhary and Mr. Sanjay Kamakar, he said the right things that nowadays it is a requirement that he rightly mentioned there is a different kind of inverter which is having the benefit of the strings and also the benefit of the string central inverter. He rightly mentioned in the last slide I saw. And another thing, the MPP voltage, which is going on the higher side, it is not beneficial for the IPP developers. It is not at all beneficial for the IPP developers because they have to lose some generation for that. So seeing the requirement, if the industry is ready to accept the mix of string inverters and also the mix of central inverter, the benefit of the string and also the benefit of the central inverters, it is already ready. Though it comes with a little high cost, I can say that. As a ceiling, we already have a 3.15 megawatt of such inverter, which works at 1500 volt and also very suitable for the Indian market. People, those are concerned about the benefit of string, and also they don't want to lose much generation, and they concerned about the central benefits. For those, it is a good solution. I can say one thing, since the market is new for such kind of inverter for the India, but in China, such inverters, they are top runner. In China, the different practice, whatever you have developed, you need to install in some power plant, and the China government, they will go for the evaluation, they will declare which one is the profitable solution for the whole country. They do it for themselves, but it is a benefit for everyone. So in that case, the India, China, means the Sinning, they have the only solution, this thing, distributed central inverter. And it was the top runner among the all kind of I'll mention again, all kind of string inverters, whatever is available in China market. The top runner product is Sinning CP series inverter. It is ready for India. But in India, there is a requirement. They want to pay less money. They don't want to have all the benefit. That's why only CP is not popular here. And only central inverters, either string inverters, that is popular. Another point, I will come back to Mr. Chaudhary, CEO AM Solar, respected person. I want to mention that if, because he made a very right point that technology is changing very fast. So what people need to do, like Mr. Pathak has already said, they want to have all kind of spares for the long life, for the 25 years or for the 30 years, whatever it is. But that need to be accounted in the contract. If they really want, it comes with the cost, because it is an electronics market. Many things are changing, and for such change, manufacturer, they need to have some capacity in terms of monetary. They need to build the portfolio for you. Otherwise, it's similar. I can say similar, like for the mobile industry, things are changing very fast, and you cannot go back to the older technologies. But if there is a requirement, then one need to sign LTSA contract with any inverter manufacturer so that they can keep sufficient spares for you. And if that spare is not available, then the relevant spares they will provide to the developer. I feel so. So this is really a demand. If the same inverter need to be used for 25 years, then such provision should be maintained. In my opinion. Otherwise, in any case, 5 years, all are binding to provide that. Thank you, sir.
Thank you. Yeah, any questions from the audience?
Sir, we have one question in the chat box from Mr. Satish Chandra Joshi.
Yeah. So read that question. Kya, what is that question? Is the can.
If any of the panel members can take this question, sir.
Yeah, this Kumar. Which question you are talking? This I can see two questions are there.
What capacity inverters are being manufactured in India? Are they going to be 1500 V level from 000 V level for central and 185 kilowatt to 275 kilowatt?
Okay. So this inverter person can reply this.
Yes.
Thank you,
sir. And it is a very valid question. So first, I want to declare that this 275 kilowatt, it is in the existence. It is already being sold now and for the India market. This is true. Another is after 2 years, you're going to see a lot of change in the string inverter market. Basically, the voltage level is about to change. We were expecting a year before, but because of this COVID lockdown, there many of the plants has been postponed from the commissioning deadline. So now maybe from 2024, you are going to see a lot of change in terms of the DC voltage. So first, this 275 kilowatt is in existence. We are already supplying for the India market, though we are facing a lot of challenges just because of the raw material unavailability. But it is there. Technology is proven. We have all the certificates. We are already selling it in the India market. Yes.
So we have one more question from Mr. Lalit Chauhan. Any more compensation for reactive power to avoid bad power factor?
Yes, recently what we have seen from the Gujarat and from the Rajasthan location, different kind of requirements are coming from a different kind of department. Maybe Mr. Karmakar, Mr. Karmakar, he might be aware that PGCL has a different requirement, state department has a different requirement, CIG has a different requirement, but NLDC, they have altogether different requirement. They want to operate a plant at a 0.95 power factor. These things are capable, but industrial regulation that need to be regulated so that all can have only one scenario. Means as a manufacturer, we do have a 3.125 megawatt, we do have a 3.4 megawatt of inverters, but depending on the requirement, only we can sell. If it is not required at 50 degrees centigrade, then we cannot sell. This is the plan. This is the problem here. So if government gives more a clear picture for these things, then we are in a position so that we can push our product to the IPPs and to the EPCs. Like as of now, what I have heard that 0.95 power factor at 50 degrees centigrade is required. It is somewhere it is written, but somewhere it is missed. So we are not sure how to handle this. There's a lot of ambiguity. So to you, Mr. Karmakar, if you want to add anything.
Yes, it is difficult for developer as well as for manufacturer also, because the regulatory requirement they are very stringent now, and as per the CA regulation, something is mentioned that too there is a not so clarity, and the different government department is asking different kind of study report, and they are also delaying the approval process actually. So that is a very difficult things for if you ask any additional type test report from the manufacturer, that also take a little bit time also. So there should be some mechanism, there should be some listing or some procedure that should be applicable to all the places, all the RLDC, C2, and all the statutory bodies. And there should be some guidelines also that what are the actually requirement from the manufacturer, from the developer point of view, so that all the party will be in a single page, and that also give a timely means getting the approval and also the commissioning of the project. That also beneficial for the country also. So this is now a bit little bit difficult. Facing all the parties are facing difficulty in this.
True, Mr. Subir.
And reactive power requirement, that is also means 0.95 is a CA requirement, and now means the grid operator are asking to operate the solar plant at with at least 5% reactive power support to the grid. That is requirement, and that requirement will going to come all the for all the project. But during the project construction, the many developer not taken consideration with providing 5% margin at 50°. Regulation also very silent on this, whether it is required at 50° or it required any temperature is not specified. So if there will be some clarity, then it will be beneficial. So
I really feel very astonished because you mentioned very, very right things. What the industry is going to face in the near future, because grid is unstable. If I talk about 245 kV or 400 kV, those grids are more vulnerable for such kind of atmosphere, because most of the plant, either they are 100 megawatt or 300 megawatt, they are going to get connected with the grid, and the voltage is going to destabilize. And for that, if I talk about the stories of the 212-13, on that time we had a provision of putting the SVR generators maybe in Wanpo or somewhere other locations. But as of now, the grid is really unstable, and we see a lot of challenges what the IPPs are facing. That's how they're coming to us as an inverter manufacturer, of course, to maintain the grid voltage. And this guideline is not specified in all the documents. This is the problem what IPPs are facing. So the same question is being asked, but I really feel happy that you mentioned very, very right points, how it should happen. Everyone should take care, means all the guidelines should cover this phenomena. Then we will definitely change our capacity from 3.1 to 5. We will sell about 3.4 or 3.25, whatever it is required for the new market, of course. So, Mr. Abhilash, thank you for giving me this opportunity to discuss about this topic, because this topic is started from 2022, from January onward. We see a lot of questions from the IPP players, what the problem they are facing for this segment.
Regarding this, I recall one incident. I was actually in charge for 50 megawatt power project, solar power project, which is in Kerala. So one day, I think it was sometimes in 2019, I received a call from KSB, Kerala State Electricity Board, that they want our help for improving the power factor in the northern Kerala. So northern Kerala, and the power factor has gone drastically low there. So then actually, then I also, being an engineer, then finally I analyzed how it will help and all that. So from Delhi, I went there, project site, state electricity, KSB people came, engineers came to project site in Kasargod. And then the inverter supplier who was in Chennai, then he came, representative came, and then we sit together half a day. And then finally, in that way, we helped actually whatever that they wanted to use. This are actually solar project, solar plant. So probably what they wanted, this to improve this reactive power using our capacitors bank, something like that. That was there. So instead of what you mentioned, that this power factor means going down, instead we have helped actually that electricity board or means distribution company for improving the power factor from this solar power plant. So that was the incident.
In the near future, like how we are increasing our demand to generate electricity from the renewable energy, this phenomena will become very common.
Yeah.
In near future, in the very near future.
So, Mr. Anand, I think now all panelists have put their views and very nicely. So now I think there is a clear roadmap how this inverter technology will actually move forward in the future. And it is like earlier, I think it was a 700-800 voltage, now 1,000-1,500. Now I don't know where it will end. So like a miniature, what I saw, the inverter size in 1986 or 1982, and what I see today, it is entirely different. And of course, the technology has changed also quite a lot. Then I think Mr. Pathak, he has put the terms mean time between failures. So this terms actually generally used in a reliability. So for more than 8 years, I was in charge for environmental engineering group, where I was in charge for testing of environmental testing on this component, sub-assembly, equipment, etc. So then that at that time, I remember one course I attended that was a Air Force, America, US Air Force, and on reliability analysis. And that was in a Indian Institute of Cultivation Sciences in Calcutta. So in that actually, this was only totally on a reliability, how actually this done. And in fact, what I recall, this today this take a inverter also means now it is a quite reliable, or even take any electronic equipment. And how it has happened, because now rigorous training, actually not rigorous testing of components, and then the that how MTBF actually brought down, so that this actually means the equipment always can keep in a always ready position. So so that is what actually this technology has in last 40 years. What I saw when student, I used to think actually, oh, we are actually in a very advanced stage. But now what we see today, and of course, I'm graduated from IIT Delhi. So then, of course, that was a much ahead of other engineering colleges and all advanced courses. But what I saw, and that is nothing in 40 years back, but now it is many times. One more incident I remember, somebody has put what this small mobile can do, means communicating those equipment gone on moon in 1969. So at that time, whatever the communication equipment, that is a much inferior to our mobile, which is in our hand. So that is actually technology has moved in a different way, and what we see today, entire world is a different. So Mr. Anand, I think now it is okay. We can conclude it here.
Yes, of course, sir. Actually, our CEO, Mr. Anand Gupta, is not available.
Okay.
So on behalf of EQ International Magazine, I would like to give the thanks note, and we would like to show our gratitude towards all the panel members today, including Mr. Arun Chaudhary from Sunny Electric, and he has given us the opportunity to host a webinar for them, and Mr. Abhilak Singh for the good moderatorship, and Mr. Subir Karmakar, our keynote speaker, who has given a very good presentation today, and all other panel members, Mr. Ashutosh Singh, Mr. Sanjeev Cham, Mr. Srinivas, Mr. Sarvesh Singh, Mr. Chaudhary, Mr. Sudhir Pathak, and Mr. Sanjay Singh. Thank you all.
Thank you.
So before leaving, I really want to thank everyone, because Mr. Abhilak, he really bring up a lot of changes what has been done from past 20 years to the Indian market. And a special thanks to Mr. Subir, who really cared to mention what is about to happen in the Indian market after 5 years, and what is happening as of now, and the requirement from our co-panelists, They really mentioned what the problem they are feeling and how we could have done better to provide the better support to them. Like Mr. Srinivas, he rightly mentioned that this heat hunters, being from the Indian market, it is really important. But maybe some other manufacturers, they are still in the development phase, but it is a requirement. It is required if you really want to see the performance at the site. And Mr. Subir, who mentioned about the CP technologies, how the inverters can work for the future environment, what is the required, the mix of the advantage of the string inverter and central inverter for the Indian market. And also he mentioned very wonderfully what can be done for the near future. So I'm really thankful to you and everyone. You have given me opportunity to speak a little bit about the company and about the product. I hope that I can, means on behalf of my company, I can prove myself and give you the most of the solutions what is required in the near future. Thank you, everyone. Thank you, Mr. Abhilak.
Thank you.
So
Yeah,
thank
thank
you.
you. Yeah, good day. Bye-bye.
Thank you, everyone. Bye.
Bye, sir.
Thank you, everyone. Thank you. Bye.
Bye.
Yeah.